Unit 4, Lesson 1, Primary Trig Ratios. Recall from grade 10, the Pythagorean theorem is a squared plus b squared equals c squared, and it helps you to find the side lengths in a right-angled triangle. Okay, the only thing you need to really remember, the hypotenuse is always labeled c. That is very important. A and b are interchangeable, but c has to be the hypotenuse. Okay, we also learned about primary trig ratios, and they are listed here. Recall, you can remember them through the acronym SOHCAHTOA, and they help you to find the measure of angles and or side lengths in right angle triangles. Example 1, solve for x in each of the following triangles. So here x is on the hypotenuse side. So the first thing you always want to do is label the side lengths of the triangle A, B, and C. So remember, A and B, it doesn't matter which side is A or B, but C has to be the hypotenuse. Then write out your Pythagorean theorem, plug in your values, and then solve for C. Okay, pause the video and do the same for this triangle. Solve for the length of x, and then compare your answer to mine when you're finished. So there's your final answer. Example 2, solve the following triangle. So when you're asked to solve a triangle, it means find all the unknown angles and sides. So the first thing I'm going to do is I'm going to find angle A using the sum of the angles in a triangle theorem. And I always recommend that after you find a value, put it into the diagram. So now that we know all of the angle values, let's work on getting the rest of the side lengths. So we still need the value of side B and the value of side A. So let's use our primary trig ratios to solve for these side lengths. So to solve for the side length of A, I'm going to use sine theta, because that's a ratio that incorporates the unknown side as well as a known side. And I'm using 35 for the angle. You could have done something similar using 55 as the angle with the appropriate trig ratio. So let's plug in our values. So sine 35 is equal to A over 7, and now let's solve for A. Okay, so we now know that the length of side A is 4.02 units. Now let's find side B. And again, there are many ways you could do this. I'll use the 55-degree angle for this one. Okay, so B is opposite to that, and our known side is the hypotenuse. So I'll use sine of 55 degrees. So our length of side B is 5.73 units. Okay, now we've solved our triangle because we have all the values for the sides and angles. Example 3. From an airplane, which is 1,500 meters above ground, the angle of depression to an airport is 5 degrees. Determine the horizontal distance to the airport. So that means this must be the airport. And we need to find the horizontal distance between the plane and the airport. So that's this value here. So let's go ahead and solve for some of the values that we know in the diagram right away. For example, we know that using our Z pattern, this angle in here is also 5 degrees. You always have to state the rule. Now we have a right angle triangle that incorporates that x value, so we can use our primary trig ratios to find x. So when you're trying to figure out which primary trig ratio you should use, if you should use sine, cos, or tan, look at what you're given, right? So this is the angle we're given. We have the side opposite to it, and we need to find the side adjacent to it. So we want to use tan because that includes the opposite and adjacent side. Now we'll solve for x. So therefore, the horizontal distance to the airport is 17,145 meters. Example 4, Dave measures the angle of elevation to the top of the city center's north tower as 64.5 degrees. He is standing 41.6 meters from the base of the tower. His eyes are 1.8 meters from the ground. How tall is the building? So let's label this diagram. Let's incorporate the values from the question into the diagram. So first, the angle of elevation to the top of the north tower is 64.5 degrees. So that's going to be this angle right here, because there's our angle of elevation. We're also told that he is standing 41.6 meters from the base of the tower. So that means that both these side lengths are 41.6 meters. We know that his eyes are 1.8 meters from the ground. So from here to here is 1.8 meters, so that also means that from here to here is also 1.8 meters. And we need to find how high the building is. So we need to figure out the distance from here to here. We already know what part of that distance is. We know that part of the tower is 1.8 meters tall, right? So if we solve for the remaining height of the tower, we can add it to 1.8 and know the full height. And this is great because that remainder piece is the same as the side of this right angle triangle. So we can use this right angle triangle to find our value of y. Okay, so I'm just going to redraw that right angle triangle that I'm talking about for those of you to see. Okay, so that top piece of our diagram. So we have y, we have 64.5, and we know that this is 41.6 meters. So let's use our primary trig ratios to solve for y, because this is a right angle triangle. So we have this angle. We need to find the side opposite to it, and we're given the side adjacent to it. So we need a primary trig ratio that incorporates the opposite side and the adjacent side. So we'll use tan. Fill in our values. And now let's solve for y. So remember that 87.22 meters is just a piece of the tower. It's not the entire height. That represents just this top piece. Okay, so to find the entire height, we need to add together that top piece with the 1.8 meters. So therefore, the entire height of the building is 89.02 meters tall.